Great, thank you. So we're going to kick off the next panel of the day, which is unraveling the test complexities of non-terrestrial networks, NTNs. And I have two panelists with me today. I will let them introduce themselves in one sentence, but no more. So starting with Jason.
Jason Trembley, I'm Vice President of Commercial here at Terrestar Solutions, Inc., the only Canadian MSS satellite operator in Canada. That's one
Go for
sentence.
it.
I did my best.
It is. No, that's good. That's good. That's good. That's good. That's good. Go for it.
Hi, I'm Randhir. I'm Randhir Choony from Stevenage. I am from VIAVI, and I'm the solution architect for NTN test solutions.
And I'm Fogg. I'm an industry analyst. I lead the networks research practice at industry analyst firm CCS Insight. So let's just jump straight into it. What are the different approaches to direct-to-device NTN? Let's start with that, just set the scene of what's happening in the market. I know, Jason, do you want to jump in on that, and then we'll pass it across?
Yeah, absolutely. So I'm trying to remember how long ago it was, maybe 2.5 years ago. We saw two major moves happen. The first was about a week apart. You had SpaceX and Apple both announce direct to device capabilities through everyday smartphones. The two approaches, of course, were different. One is hardware OEM based, and the other one utilizing terrestrial spectrum. But of course, there's a third that's emerged as well, non-surprisingly, with I would say incumbent MSS spectrum holders with satellite spectrum that is actually meant for this kind of thing. So yeah, I would say that those are probably the key three approaches.
Yeah, I mean, I think it was the iPhone 14 range back in September 2022 that Apple pioneered their initially emergency messaging before they expanded it to wider two-way text messaging. Are there other differences here in terms of the types of direct-to-device service?
I think there's also the nuance between LEO and non-LEO. So
Sure.
with the incumbents, you have geostationary players who are the incumbent MSS spectrum license holders, specifically in the SNL band. And you have the new sort of LEO players that don't own spectrum but have launched LEO capabilities like the AST Space and Link. So that's a bit of an overview.
From a VIAVI perspective, are there other differences in the approach that are relevant to the rest of the conversation, the panel, Rhonda?
Yeah, I guess the approach you have taken is right. If you think about direct to device or a NR NTNU is, so basically the direct to device is there's no hardware changes, right? So there's different target market for that. So if you look at the challenges of a satellite link, one of the main challenges is the propagation delay. So there's a huge round trip time delay, especially with GEO. LEO, not that much, but compared to terrestrial, still quite significant, right? The other bit is, as Jason mentioned, is there's a shift towards LEO. And with LEO, you have to deal with a high Doppler shift you can have on the satellite link. Again, another change is the link variability, right? So if you think about it, satellite, especially with LEO, satellite is moving all the time and is traversing different environments. You can have huge, mountains, urban canyons. So you can have a shadowing effect. The channel is changing all the time. And you won't face that with terrestrial, for example. And especially if you're going to the higher bands, the Ka band and Ku band, you start having rate fade and so forth, right? So there's a big change, between the channel on terrestrial and the channel on NTN. So I guess to come to direct to device, obviously the U itself can't deal with these different challenges on the channel. So all this kind of smartness needs to go on the network side, right? So the GNOV or the run has to incorporate complexities there for the direct-to-device. But going forward, if you look at an NL and NTN UVs, many of those complexities have shifted towards the UE. So I guess, there's a how to say, so they are looking at capturing the market now because they can target existing UEs, right? And then if you look at the roadmap, as the chipset manufacturers start learning from the experience now, they will start, changing the standards and putting new technology on the chipset to deal with these challenges.
So essentially, there's a few differences. There's the shift from GEO, which is the historic thing we've had since the 1990s, I guess, from the original satellite constellations for satellite phones, to LEO, so low Earth orbit constellation where everything's moving very quickly and it's much closer to the ground. There's the difference between standards-based service on the 3GPP path and proprietary. There's difference in the type of spectrum used, whether it's reuse of spectrum by the operator or whether there's new spectrum available that's licensed to the constellation. And there's obviously different constellation vendors out there. I mean, a few have been mentioned already, Globalstar, Starlink, but there's others. There's AST Space Mobile, there's Link, there's a bunch of Chinese guys. There's some IoT specific constellations. There's a lot out there. I guess the momentum is around LEO services now. What kind of services are possible on the current LEO constellations? And what's going to come next? Where are we going with this, with the LEO constellations, and the type of service that people are going to be experiencing that we need to test for?
Is that for me or for Randhir?
Go for it, Jason.
Okay, sure. So, look, the existing GEO satellites that we utilize today that are 38,000 kilometers in the sky are obviously less than ideal from a latency perspective. You couple that with the fact that you've got small devices on the ground trying to connect with them and limited antenna capability to connect to it. We're hoping that in the next couple of years, at least one of the things we've promoted is our ways to get some antenna gains over the existing NB-IoT protocols in phones so that you could connect and as a result get voice gains. You need a certain dB in order to do it. It's not easy to do it, and we're testing a lot of voice compression technology to get it to that reasonable level. But to get it to the point where it's really ubiquitous and probably more in line with what we're used to seeing as a standard voice on the ground, you're probably looking out to 5G NR and having it sort of standardized in the everyday device under that particular protocol. The NB-IoT protocol that exists is very narrow and requires a bit of bending beyond what it was originally meant to do, which is narrow band. So yeah, I mean, I don't know. Yeah.
So if I summarize that, you could say we've had the emergency messaging over a narrowband solution. We've now got two-way text-only messaging, and then the next thing is potentially voice, potentially.
Yeah, you've had SOS and text certainly happen in an NB-IoT protocol. You've also had it happen directly with Apple and the proprietary chipsets that they've manufactured with Globalstar. But yes, I mean ultimately, it's not that it's impossible; it's completely possible. OEMs just need to think of innovative ways of doing it. For instance, we patented or have patent pending an antenna sleeve that actually locks onto the back of the hardcover of your phone, and if those get integrated, well, then you can get the antenna gains you would need in order to do it. But after that, does the ecosystem incorporate it? It's a bit of a chicken and the egg, constant challenge in our business, as you can appreciate. So yeah, that's kind of where things are at.
Are there any additional services that you're expecting into that migration on the LEO side, Randhir?
I guess as Jason said, right, what are we today? We're doing messaging, right? And going forward, 3GPP is pushing NTN in the spec. So if you look at the roadmap, we're looking at LEO constellation, right, to be an enabler. And voice call is the next step, right? And for that you need two things, right? You need more bandwidth to get more throughput through, and then you need to have the problem of latency, right? So with the latency we have LEO, you can have acceptable calls, right? But even with LEO, you have variable latency in the system. So looking forward, there'll be more ways of reducing latency. So for example, if you have the region satellite can talk with each other through inter-satellite link. So traditionally, with a star topology, the data needs to come back to ground to a gateway before it goes up again, right? So with a mesh, if you think about a mesh where the region satellite can talk to each other, then that's a way to reduce the latency across the ecosystem, right? Although today they have the voice call over LEO, but they have optimized the link and they have used the shortest link, the shortest latency. But if you have full-scale deployment, then you need to look at reducing latency across the system and probably having a mesh network. That will be the way forward to reduce the latency. And then, once you reduce the latency, and if you're going to the higher band, right, the K band or the KU band, where there you have much higher bandwidth, you can have higher throughput for the system, then you could see other systems coming in, right? You might have video streaming, for example, and you have enough buffering in the system that could work. There's other stuff that will not work, right? Like, for example, gaming, when you have interactive experience, that will not work. But definitely voice and streaming stuff, is on the roadmap, and the spec is continuously evolving to enable this kind of application to be supported on the system. So, example, if you look at handover, because obviously with LEO you have constant handover and you might have interruption in your service. So they're constantly changing the standard to make that interruption as short as possible. So you could see they are engineering the spec to try to meet these different scenarios or different applications that the NTN would support.
So I think you've highlighted a bunch of ways in which the LEO architecture is potentially very different from testing, say, voice on a cellular network, because you've got that constellation, you've got variable latency. Are there some other differences that you can see, Jason, in terms of how testing NTN is different to maybe what people are familiar with in testing cellular on the ground on terrestrial? I'm not hearing you, Jason. Is your mic working?
Apologies. Apparently, I went on
That's
mute.
it. Okay.
No. Can you repeat the question again? Sorry.
I would just say so. I think Randhir highlighted some of the architectural differences with LEO in terms of how it's different from maybe a terrestrial cellular network for voice because of the variable latency, the complexity of having a constellation, as well as the distance involved.
Yeah.
I'm just wondering if there are other differences that you might see in how you might test an NTN service versus testing a terrestrial cellular network, which I suspect many of the people listening in today are very familiar with.
I think what he said really covered it. I think what people should understand, though, there's a huge PR element to a lot of this stuff. And very often or frequently, you'll see news about a test over, or a successful phone call that happened. But very often, they can happen, and I don't want to name names, but they can happen in satellites that are lower to ground than what is actually authorized in the ITU filing for commercial. So a lot of it is, I should say, smoke, for lack of a better word, a lot of PR positioning and posturing. But of course, it's very different than terrestrial because you're dealing with Doppler, you're dealing with all the elements that Randhir has pointed out. So just that people are aware of it, I think is,
I think weirdly that hype is actually something we do see in terrestrial networks, where you see, I don't know, the latest
probably
millimeter
right.
wave or 5G NR, where someone says we can do this multi-gigabit throughput when there's one user on the cell and there's no one else on the cell, and it's the same kind of thing. You then put a bunch of users on the cell, and the actual average experience is much less good than that. I think maybe that's the parallel here, where you do a test, maybe there's one satellite in the air, there's one user, you can do this fantastic offering on this rich service, but you couldn't scale that because the capacity to, a mass user base. Maybe there is actually a parallel here.
Correct. Correct. I agree with,
Maybe.
I agree with you. Yeah, no, I agree with that.
I think
I mean,
there's another piece
Yeah.
that Randhir was touching on, which I think is interesting, is that I think a lot of the geo satellites are what's called transparent, which means they basically just pass through the signal from the ground station. With some of the LEO constellations, I think the effort now is to put more of the active electronics, the base station itself, into the sky. And that's one of those enablers that then enables the mesh, as I understand it, and adds a lot more flexibility for the constellation, but probably more complexity in how we might test it. Is that a good summary, Randy?
Oh yeah,
Or Jason?
yeah. Yeah, I guess yeah. So I guess there's a hype there, right? I mean, there's a parallel with 5G. When 5G was coming, there was lots of demos showing all these high data rates that can be achieved. But when they had to deploy it, it's not exactly what happened, right? We still have issues of getting 5G optimal and getting what was promised, right? Yeah. So of course, going LEO and having the mesh there is very challenging, because we're looking at mega constellation with like 2,000 odd satellite. And how do you test 2,000 odd satellite, right? And so there's complexities all around the system, right? So we talk about Doppler timing and so forth, right? So all this can be tested. But again, there's other aspect of it, the security aspect, where you have open interfaces. Usually those beams are quite wide, right? So people can break in. You could have people try to hack in, or people try to jump the uplink. There's other aspects that is there in a terrestrial, right? For example, you can have fiber up to your base station, and so you have to have physically you have to get access to it to do some hacking, for example. But with satellite, the uplink is open, right? So people could do jamming. There's other other test cases there that need to be exercised before this can be fully be deployed. Yeah. And that's not saying, there's a basic thing it's doing, right? All the functional stuff that has been put in place by 3GPP to deal with the delay, the Doppler, the beam management, the power control, all these are the basic stuff that needs testing. And you think about all demo has been done, the voice call or the browsing has been done. That's just showing that it is possible, it is feasible to do it. We can do it for one UE, right? It is possible. But obviously, there's still lots of gaps, right? It does not show at scale how that will work, right? If there's outages, how it will work. If someone attacks your GNSS, what will happen? How the routing will work, how the beam management will work. There's loads of aspects. Doing one demo, will not tell you what will happen, right? So you need to try to bring all of these different use cases potentially in the lab and try to implement the scenarios and see what the ways you could optimize the network and potentially, optimize the network, but also help you to understand what new thing needs to come to the standard to make these things actually practical.
I guess the question here, Jason, how you communicate the proposition to governments, to regulators, to end users on this, given there is all this complexity in NTN in terms of the types of architecture, the solutions, and then the information coming through on the test side. I mean, how do you manage expectations? How do you communicate this?
Well, it's certainly a challenge. What we have the advantage of is, of course, owning our own spectrum. That's the first part. We don't undergo the same level of complexity that's often associated with lower band terrestrial spectrum from an interference perspective. or from a packet EPC and packet handoff perspective, because trying to use an LTE protocol in a satellite creates a heck of a lot of complexity. We don't have the complexity of the LEO yet, but that's coming with Doppler shift and everything else. But I think we're managing quite well around that, from our own perspective, and from when we plan to actually launch the LEO constellation. So, and the fact is that we kind of always viewed ourselves as integrated with the MNO and cellular ecosystem, which I think is important, because a lot of players tend to think it's, well, and maybe it's to their detriment, tend to look at it from almost a standalone, whereas really it's about integrating with the MNO and becoming sort of an extension and overlay of their network, rather than trying to compete or to be something supplemental. It's very important to look at it in that vein. There's the whole customer ownership and customer management and provisioning. This is an effort that has to be done with mobile network operators in order for it to be successful, no doubt. The question,
I think, go on.
no, I think the question is just through what means do we do it? And the only long-term scalable solution for us, at least, is an MSS spectrum provider to work with.
So I guess that integration also means that when you're testing the experience, you need to test across terrestrial and NTN together in that relationship on how those connect as well. It's not a case just testing NTN, you test the handover situations.
100%. It'd be too simple if we could do it that way, but no, we have to do it hand in hand with mobile network operators. It's the only way we succeed.
Right. The other thing you were alluding to there, I think, is some of the hype around satellite potentially replacing or cannibalizing cellular, and that there's some parallel there with what happened in the past on Wi-Fi. You said Wi-Fi would replace cellular. The reality is you have this complex layer cake with more layers going onto it. That's how I'd frame it. It would now be a case of not whether you have connectivity, which is what we had in the past when you went outside of Wi-Fi and cellular. Now it's what kind of connectivity will you have? And that goes on to when you go to the NTN, what kind of NTN service is supported by that NTN solution? Is that a fair comment in terms of the interoperability questions there and the challenge of testing that around it? Sorry, go on, Jason.
You hit the nail on the head, Ian. That's exactly how we view it, at least at Terrestar, is it's that sort of fourth access point, or that fourth way of connecting, beyond Wi-Fi as an overlay of that service, not just an extension, but also overlays on top. And at which point mobile network operators can manage how they want to load and offload traffic. I mean, that's really what it boils down to.
Any thoughts there on the testing challenges of that handover piece, particularly, I guess, Randhir?
Yeah, I guess from the testing point, right, you could kind of separate into two types of testing. One would be like the run testing, where we talk about the challenges over the air. And the challenge would be end-to-end testing, where there's like integration of the terrestrial network and the non-terrestrial network. So there, end-to-end basically means, from the data all the way through the core to the UE. Obviously, there's lots of stuff that comes in, lots of procedures that has come into NR, where there's handover between TN and NTN, and they have put in quite complex procedures depending on how far your satellite, how far you're from your service time, and they have put in complexity around how to minimize the handover between the two, right? So we're looking at having with the NEMs, obviously having solution where we could test this between TN and NTN and recreate many of the scenarios in the lab, where we can emulate the scenarios and see how practically you can offload from TN to NTN. And obviously, I mean, one thing to understand is with the satellite, right? It's moving across, is it? Moving across the space from one territory to another. You might think about there's regulatory constraint, right? You might not have a service from one region to another. One region might have NL, one region might have LT, for example. You might be able to transmit on certain band in one region to the next region. So as from the satellite point of view, if you look at the names, it looks at reconfigurable payloads they have on their satellite. So as moving from one region to another, they might want to change from NL to LT. They might want to change the bands operating at. They might want to change the beam management, right? And, you know, obviously, the handover also needs to happen, right? So if you think about that users having service from a TN, and then it moves out, and then it goes to an NTN region, and that management needs to happen. And obviously, from VIAVI, we're conscious of that, and we try to provide different ways. It could be through, you know, quite expensive ways using a channel emulator, or, you know, more affordable solution where we have multiple UEs, and we can have some UEs which is on the TN, and we have some UEs on NTN, and emulate the scenarios which would trigger this mobility. Yeah.
So we've got some questions in the chat too. Please fire more in. I think we've got a minute or two left. Let me just fire a question to you guys. So there's a question about what's the biggest complexity challenge that is hitting the market from a cost point of view? Is there something that jumps out at you guys for that? And try and do this quickly so we can get another question off this too.
Sure. I would have to say that, you know, you've kind of got two dynamics, right? You've got companies with deep pockets who don't own spectrum, and you have companies with spectrum but need deep financing, and satellite is a capitally intensive business. I mean, even before launch, you are deploying millions upon millions of dollars to do it. It's a very capitally intensive business. So attracting that private capital, you need a lot of government support in order to do this. I would say absolutely the satellite and the launching and the whole thing. It's a very CapEx intensive business. So I hate to be very general on that question, but that's certainly what preoccupies us.
It's a big one. So quick one from you. What's the biggest cost complexity driver from your perspective? Sorry, VIAVI.
So again,
What's the biggest complexity driver of cost issues is the question, if you just wanted to pick out one.
Yeah, I guess I think I've just alluded, right? I mean, to launch satellites, it will like a couple of billions, maybe $1 billion or so. And initially, there's lots of players that came in, and they want to go into that business. But at the end of the day, there will be, you know, a couple of players there, right, to have satellite constellation up there. So the whole point is there need to be tight integration between the MNOs, the network, the NTNs, right? So there needs to be a lot of synergy coming in, and also we need to sell that, right? Because what is generating the revenue? Currently, just an add-on. So somehow the revenue to be generated to finance that business model. And the next bit is LEO is a way forward, and that's mega constellation. And we say to get that to work, we need to start getting all this mesh working, right? Get the mesh network working, and the mesh itself, depending from one region to another, might be different in the sense that they might be provision to offer different capacities in different regions, right? So if you think about the satellite going across on the Sahara Desert compared to going over a city, the provisioning is different.
So let me fire a different question to you guys. We've got some very technical questions in the panel, which I'm not sure you guys are the right people to answer. I'm looking at the chat, but they are interesting questions. There are many other services that are now relying on NTN from fixed broadband. Obviously, Starlink is high profile on that, but also IoT, where maybe you just need a satellite in the sky once or twice a day to get a kind of quick bit of data up and down. How does the range of NTN offerings affect what you guys need to do from a kind of assessing the quality of the network, communicating it, when you're straddling between potentially expectations being set by what fixed broadband can do with a big antenna, what you can do on a smartphone with either a dedicated or an adapted device, what you can do on an IoT module, which are all quite different, but they're all relying on potentially the same LEO constellations. How do you think about those different dynamics?
You want me to go take that one? So
Yeah, sure, go.
IoT, there's variances in IoT. So you've got use cases where you only need a ping or two a day, and there's others where you need that constant stream. So depending on, but typically you're dealing with very limited bandwidth requirements on IoT. So geostationary solves for most of those cases, at least we've seen it. Whereas LEO becomes more of an
Even at Canadian latitudes, even that far north, you're finding that GEO will do it for you guys.
Well, yes and no. It's a fair point. When you get up into the Arctic and you don't have that GEO coverage anymore, that's where LEO becomes important.
Yeah.
But you probably need less consistent LEO coverage in order to do most of the use cases you want to do. When it comes to more consistent kind of streaming of information, obviously you need a massive LEO constellation so that there's that continuity overhead on a consistent basis. But go ahead. I know we're limited on time.
No, it's fine. So one last thought on that from you, Randhir?
Yeah, I guess to be fair, right, IoT is quite suitable, right, for satellite, because most of the use cases are you don't need to have streaming data, you just need to have a burst of data, So yeah, so there's changes in the spec where so that device will store the data for a while and then just burst it up when satellite is over. So yeah, so we can see that, I mean, we have seen that lots of our customers are interested in LEO and VIAVI compared to GEO. Obviously, GEO is the traditional IoT solution, right? But even now, they're looking at to use LEO because
Great.
Yeah.
Great. So I think that's where we focus so much on the smartphone piece. Is the fixed piece is more predictable because it's one location, more predictable. IoT, we're not quite so demanding to the network requirements. It's on that direct device smartphone where the device is moving. You've got the LEO constellation. You've got this shift to maybe real-time voice where it gets more challenging on the testing side, which is why we focus so much on that in this panel. We're out of time, so I'm going to say thank you to my panelists and hand it back to the event organizers.
Thanks for having us.
Thank you.